Okay guys, see this theorem. Okay, this is nothing but a extended version of a product rule. So product rule means we have talked about only two product, like product of two functions basically. Now here, what will happen if we have many functions in product or in multiple? So in that case, nothing but we have to follow the same procedure. We have to keep one by one terms as it is and others as differentiation. As you can see, here we have product of 1, 2, 3 and so on. So what I'm doing is I'm differentiating my first function, I'm keeping others as it is. Then in the second step, differentiating my second function, keeping others as it is. Then in the third step, differentiation of my third function and keeping others as it is. You can go till n terms. If you are going to write last term, so you can write as differentiation of n function and others as it is. So basically the point here is you can differentiate one by one. In product rule, we have two functions, but in product, if you have multiple functions, keep one function. Okay, just give the name or numbers to those functions. By that you can decide which function you have to differentiate. So one by one differentiate the functions and just keep other functions as it is according to the steps. Okay, so I'll just take one example for 3 or 4 numbers only, or 3 or 4 functions. So in that case, what will happen is, if we have a function d by dx of, if we have to find x sine x and we have e to the power x. Okay, I'm taking these 3 functions only. I'm taking these 3. Now I have to differentiate this. What I'll do is, according to this rule, x my first function, sine x my I can write this as a first and this as second, this as third. Okay, so now what I have to do is, I will keep first function as derivative and others as it is. It means d by dx of x and others sine x into e to the power x as it is. Okay, plus next d by dx of next function, which is my second function, sine x and others as it is. So others are x and e to the power x. Plus in the third one, because we have 3 functions, so we are differentiating 3 times, so it will be d by dx of e to the power x and others are as it is, sine x and x. Okay, simple. Now just write differentiation of x is nothing but 1. So in the first step, I'm getting e to the power x sine x, plus differentiation of sine x is nothing but cos x. So cos x and other function, which is nothing but e to the power x and x are as it is. And differentiation of e to the power x is also e to the power x, okay, into other functions, which is nothing but sine x and x are as it is. So this is my final answer for the differentiation of my 3 functions. Okay, and you can just write in combined manner or you can solve. As you can see that e to the power x is common out in all, you can take e to the power common out. You can write as sine x plus x cos x plus x sine x. If you want, you can simplify further. Okay, you can take x common out, or you can combine these terms, or you can combine these terms. Any 2 terms you can take, and you can take common out terms and you can solve further. But it is not a required one. Okay, even though whatever you will do, that is the final answer. If you have some values, initial values, where like at some particular point we are checking the differentiation, in that case you can substitute those values and you can get the differentiation value. Okay, so always remember, whatever the product is there, if even it is for the 3 numbers, 4 numbers, 5 numbers, just differentiate the first function, keep others as it is. And again, in the second step, if we have 5 functions, so we will go till 5 steps. Okay, let's see this theorem, guys. Let's see this theorem, guys. Now what we have here is division. We have done product rule already. Okay, we have done the addition and subtraction. This is called as division here. Division of 2 functions. X square by x you cannot call it as division of 2 functions, because that can be converted in 1. Okay, like division of 2 different functions, like algebraic function, trigonometric function, inverse function, and other function like log function. Okay, So what will happen if these things are there? Okay, like first of all, you should not get confused with f of 2 and all. If you're getting confused with this, you can write as u by v. Okay, previously also I said u by v rule, you can say that, or quotient rule, you can say that this one as. So d by dx, I'm taking this as by u by v rule. Okay, u as my function, one function, and v as other function. So what will happen, the rule says that I have to differentiate this u by v function. So in that case, I have to take the denominator v as it is but square, and then my function v will be as it is, d by dx of u, and minus, then u will be as it is, d by dx of v. That's all. Okay, now if this is there, okay, let's take the example, so it will be clear more with the example. So I'm taking the example, since you know, okay, I'm taking a very good example so that you can understand we are doing the right thing. Okay, so as we know that d by dx of tan x is nothing but secant square x. This thing can be proved with the first principle, but even though now I'm going to prove this with this quotient rule. So if I'm going to prove this thing with the quotient rule, what we have to do here is I will take tan x as sin x by cos x. Okay, now I will differentiate. So I can say that d by dx of sin x by cos x. Okay, it means cos is my v function and sin is my u function. Okay, so what I'll do is, according to the rule, that cos square in denominator, okay, cos square x, and cos x as it is, d by dx of sin x minus sin x as it is, d by dx of cos x. Okay, simple. Now see, cos x as it is in the numerator, I kept it. Okay, and sin x differentiation is nothing but cos x. Okay, minus sin x as it is, differentiation of cos x is nothing but minus sin x, and denominator we have already cos square x. Okay, now what we got in numerator, cos square x minus minus positive sin square x, and divided by cos square x. As we know this identity, cos square x plus sin square x is nothing but 1, so we can write as 1 by cos square x, and also we know that 1 by cos square x is nothing but secant square x. So d by dx of sin x by cos x, what we got, nothing but secant square x. So we proved it, that tan x differentiation is nothing but secant square x. So we proved that thing also, and we know how to use this formula also now. So this is what we have to do whenever we have division of two functions. So we can do directly this use, but remember one thing, that this formula should be in your mind. It is very very important to use this formula as it is. Sometimes student will just change the values, like instead of v here, here we have v square, and here we are keeping v. This is a very important part. You should remember this thing. I'm keeping v, the second function, as first as it is. Okay, so this is very important. Sometimes student will just replace u and v, and that is really wrong. Okay, and sometimes they will do the mistake in plus and minus here also. So please take care about these things and apply this theorem, or we can say this quotient rule, and solve the problem. Okay.